This session is scheduled for 90 minutes and will feature 3 presentations. This session is being recorded and will be available in the replay section of the event as soon as possible, hopefully by the end of the week, but can't promise that. We'd also like to bring to your attention before we get started that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted and the process for their adoption is transparent.
Sorry.
There it is. Let's put that down there. Where was I? Adoption is transparent and standards that are being developed do not favour any particular provider and are open, non-binding and accessible to all. So please take note of our antitrust code of conduct up on the screen. And on that note, I would like to hand over to Christof Lorenz.
Yeah, can you make that bigger a little bit?
I'll try that.
Yeah. With all the people in the room. Thanks, Sheila. So good morning, everybody. My name is Christof. Systems. I have 30 minutes to introduce you to the topic contextual digital twins using open standards and open source. The main title should be BIM goes GIS or geospatial. And the first thing I'd like to ask you is, are you using digital twins already here? Raise your arm if you do. Yeah, in my opinion, you all do. Why? When you're using like Google Maps or Google Earth, that's already a digital twin of the Earth with the environment and live data and everything. Have a seat. It's like in university, right? People are coming late all the time. It's not CT. All right. So in my opinion, and have that Google Earth thing in the back of your mind, because that's going to be the main topic. And now picture, you can take, all your BIM models and your assets and sort of put it on Earth, like in Google Earth, and do something with it. And this is what I will show today. So digital twins in construction and, a pure digital twin by definition only exists if there's a physical counterpart. So a pure BIM model is not a digital twin in a classical sense. So there's no true digital twin in the design phase because the physical counterpart does not exist. But it's the start of the design twin or digital twin journey. In the build phase, usually we already have a full digital twin. Think about the construction simulation, the sequencing, site simulation, BIM to field. So whenever there's the first part of the physical counterpart, it's the start of a digital twin. Of course, like in the let's say life cycle phase where digital twin plays the biggest role is the operational phase. We see that with D-Twin from Nemetschek and others, or iTwin from Bentley. It's always physical versus digital and dynamic versus, let me switch that off, dynamic versus live data. Operational digital twins currently are using mostly on one building or one set of buildings. It's not that, for example, if you have 100 bridges or so and you want to manage those bridges, that this currently exists. So I would ask my colleagues to stop team messaging me. So have a seat. Hey, Burak, stop messaging me, okay? All right. There is an ISO code or norm existing for digital twins for cities where use cases are defined, but that's about it. Digital twins for transportation networks rarely exist or exist on a low maturity level. I'm speaking of road, rail, and water. I will show a digital twin for waterways later on. Energy grids is a very important topic to simulate the energy distribution grids, but still that's in the very beginning. Why contextual digital twins? I think the major part of a digital twin is that it gives you context. So usually construction projects are, isolated and they require kind of a connection to the spatial environmental context for holistic understanding. And BIM and GIS or geospatial, that is usually separate disciplines. There's different exhibitions, conventions. There's limited integration, communication, collaboration. It's basically 2 different disciplines. But there is an increasing demand for transparency and accessibility that we see. And I think now currently open technologies are usually browser-based, enable you to create easily digital twins, in my opinion. So what does context mean? Usually, as I said, the BIM model is isolated from the environment. Even though you might import a terrain model and do some texture and rendering, it still stands alone. And what are contextual elements then? Usually you have a digital terrain model. Think about the globe, again, Google Earth. On top of it, there's a terrain model. The terrain model then is covered by an image layer that consists of ortho photos or map data. And then, of course, the most important part, the surrounding built assets, which is usually missing in Google Maps. It's there in Google Earth. And if you want to have Berlin as city GML data, which is schematic hierarchy data, OpenStreetMap buildings, you can have reality measures from LiDAR scans, or simple or more complex CAD models, of course. And then what else makes it's funny. What else makes a digital twin is the lighting and shadow simulation, of course, weather and climate, and then dynamic data. So dynamic data could be real-time weather, real-time traffic, and you have seen stuff like Flight Tracker 24 and stuff like that. That could be embedded in a digital twin. You see a water log system on the lower right. You can simulate the water levels, vibrations, crack monitoring for structural engineering or movement of structures. Now, at the core of everything is when we talk about streaming things in the internet, you need to have a format that it's easy to compress, loads only when it's visible on screen. And if you have ever loaded a 3 GB IFC files into BIM Vision or other applications, it takes forever and it's very clunky. That's because of the nature of the IFC structure. So what we do is we convert the IFC into so-called 3D tiles, which is by the Open Geospatial Consortium. It's an open standard. And those 3D tiles are massive in terms of performance. They have a hierarchy, and they also transfer metadata. So when I take an IFC file with metadata, the metadata will survive the transformation process and load it into the viewer. So 3D tiles, that's the thing. Now a little bit more technical, since this is open source, I will not mention any products from my company too much. So usually, and I don't know if you know that, there's 2 very good open source programs out there, applications that can handle IFC. It's FreeCAD on freecad.org and Blender. Both can import and export, I think, up to, I don't know, 4.3, but probably that's also possible, and handle IFC data. So in my opinion, very interesting. And then what happens is usually you take the model, you export it to IFC, take the IFC file, and the tiling process begins. And then CSIM.js and CSIM Ion come into play. So CSIM is a company that we acquired that delivers that JavaScript library that basically creates that Google Earth kind of application. And once the tiling process is over, the 3D tiles are going to be stored in a repository, which is either cloud-based, like in CSIM Ion, or you can just use any repository on your server, like in a file system. So basically, you store the data on the file server, on the web server, and you create an app on the web server. It's like basically a web page, okay? And then you publish it to anybody of your stakeholders out there. So again, you have CAD data, you tile the CAD data, you put it into context, create an application, and make it accessible to the public. I'll show you in the demo later. And if you're really crazy, and that's coming more and more, and you want to have those fly-through or immersive virtual reality experiences, then you can export, or let's say stream CSIM data also into Unreal. It's not an import. It's like you open Unreal and it's going to be streamed live from the cloud. The little symbols here indicate, just for a matter of transparency, CSIM.js is open source. So about like 80% of CSIM is open source. CSIM Ion is a commercial product, which is free for personal use. I'm just too lazy to create my own stuff, so I'm using CSIM Ion, and I work for this company. I get it for free. So, and also CSIM for Unreal. If people say it's for free, that's true. Unreal is for free, but it's not open source. So if you want to use an open source gaming engine for your stuff, you can use Godot or other applications. So I'm gonna switch over to the live demo now. Hopefully the internet is strong enough. About 20 minutes. So what I will do is I show you a very simple design visualization and publishing it, so you can put your BIM models into context and publish it to the public. I will do a more advanced asset visualization where you can switch on and off, let's say, IFC categories. I show you an example about asset repository and maybe a little BIM to field. And yeah, I think I should mention this, the why. I think why digital twins? Okay, so it's not about pure technology, because that would be self kind of inflicted. I think there's a true value, and especially for architects and engineers during competitions, stakeholder engagement, stakeholder management, and having better visualization for competitions is a huge leap. If you think about project management, precise visualization for decision support. If you think about the public sector, like the German railways, improved transparency, accessibility for stuff you want to build. Like there was this huge discussion around the maintenance stuff in my area from Deutsche Bahn. And I think the general public gets better access to data and give feedback and can engage in the decision and opinion-making process. And for owners and operators, like the grid operators, if you want to put your assets, and I'm not talking about an isolated single building, think about, let's say, German Railway, all the stations in Germany, all the bridges from Autobahn GmbH in one repository. It's not you load one project, they're all there and they're just getting loaded once you jump there. This is what I'm talking about. So what I show is quickly a little example. That's FreeCAD, and it's a little example of a house which I export into IFC already. I did this already. And if I load this into my application, this is the IFC file. I can double click it, and then you see it usually in BIM Vision. And if I click on the wall, you see there's the IFC entity wall, just to prove that it's really a IFC export. Now this is an editor by Cesium. Basically, it gives you the globe. And what we do now is we're going to import the IFC file quickly into Cesium by just drag and drop. The application will recognize it's a BIM file. You can give an EPSG code, which is important, because if the IFC file is georeferenced, an EPSG code will help transforming those coordinates to make it usable for Cesium. I don't have to do that, but usually it looks like this for Berlin or so, and you give a name and then the tiling begins. So basically it's uploading the IFC file, it's fairly small, and the tiling process begins. And I show this because like it's very easy to georeference something if it's not georeferenced yet. And I think technology always needs to be accessible and easy to deploy and not too complicated for all the nerds out there. So this is the house that I imported now, and it's standing somewhere isolated. And to adjust the location of that asset now, you jump into the location editor and you can give longitude, latitude, height, and the rotations or the direction. What I will do is I will go to Berlin Hauptbahnhof. So there's a geolocator. And we jump directly to the tile set. And you see here the Lehrter Bahnhof. And I know that probably down here, bring this up a little bit. So you just move around the asset probably to 100, like this, get closer. And I just position it here at the shore a little bit so you understand what I do. It's in the middle of the water, just move it over there. And that's it. And then you save simply the location. So that's all. Now what happens is if I want to publish this, you create a vision or a viewport, and then you import the asset, which is in the database. And you can directly jump to the asset. And it will load. Okay. So interestingly, down here I already have a terrain model loaded. Of course, I can switch this to Google 3D tiles that you probably know from Google Earth, which is similar but not exactly the same. And then you see that the terrain model is changing a little bit. So Google Earth is using other coordinates. I have to lift up the building a little bit. Just move it. Okay. Save it. So I created a first, let's say, viewport. And just to show you how that works, I can create another one. And for the next one, I maybe change the view from this side. And you can already see that, oh, the OSM buildings are loaded. So that's Berlin full in 3D with my model. And I just capture this view and leave it untitled, and then again go to the initial view and you will get the picture. Let's do it this way. Capture view. So what we did now is we created more or less the sphere, Google 3D tiles on top of it with my little tiny house, and I created 2 viewports. Now I want to share this, okay? Now this is very interesting. Now it can create a URL that I can publicly share without a token or anything. So if I copy this and bring it into my browser, I can send this URL to any of my stakeholders and they will get this viewer. And this also works. And I give you later a QR code. You can use it on your mobile phone today as well. And it directly jumps to my building. There's a little widget on the lower left here. There's my building. And the widget will also give you a little measure widget from which I can, sort of measure distances or areas on the asset. This is how far it goes. Now, I created already a larger project, which I will show you later. So in a nutshell, and again, this is like a story I just created, and I will give you this later in a QR code. You go through your mobile. So Cesium will give you basically the Earth. It will give you the true moon. So it will show you that the moon is not flat and the Earth is also not, but the moon is not real. It's just all props from Hollywood. You see it here. It will give you Cesium world terrain, which is basically a terrain model with a reasonable resolution, showing here the Switzerland Matterhorn. Then when I talk about digital twins, we need buildings of the built environment, but those buildings are probably like this LOD2 GML type of style. This is Vancouver. If I click onto it, it gives you the metadata. And maybe I should have shown that, of course, here in this example. I show later. That's better. Next is City GML Munich. It's also a standard that is coming from the official authorities. It will give you Google 3D tiles. We have just seen that. That's probably Berlin. Sometimes it takes a while to load, but here you have, let's say, the Brandenburger Tor, and I think we are somewhere up here. So that's all the content usually a digital twin will give you from a geospatial kind of perspective. So now my project, and I think I have, how much time? 10 minutes? 10 minutes, good. Yeah, so I'm going to be quick. So what I want to do is I want to take my house and position it here. That's in the middle of, I think, it's the United Arab Emirates, and this is the situation. It's Cesium world terrain. It looks, the order photos, of course, because they're order photos, it looks all like flattened. So what I will do is I will position my simple house here, which I call simple house. And you can see that I position it here at this place. Okay. Now, usually the terrain model coming from Cesium terrain might be fairly old, and especially around those infrastructure projects, and not very accurate. So what I did is I also created a point cloud by photogrammetric reconstruction of that bridge. That usually looks very impressive, but it's useless because like point clouds are not very good to measure from. So I can also create from the same data a reality mesh. So, and I cannot demo it now, but I have a webinar at 12 o'clock if you want to see it more. So we take about 0.5 GB of pictures, just pure photo pictures, no LiDAR scan in terms of, and there's a photo reconstruction that creates that reality mesh. And once we created the mesh, we see that my house disappeared because, let's say, the local terrain model looks completely different, the current one. So what I will do is, of course, I take my house and just move it up. Okay, like this. Save it. Now the house is positioned on top of the real terrain. So the next thing is probably there will be more houses. So I think that's a good thing. But then my neighbor is saying there will be another house over there. And that's an example from BIM Collab. Probably people know this. And it's kind of odd because like the foundation slab in green is still here. So it's not very nice. But I'll show you later on how to erase this. And there will be a complex building down there in this valley. Some crazy architects thought might be good for water and flooding to test it. You might recognize this is from Nordic LCA, those IFC files you can use for testing. And of course, like my house here, and they have a huge street here, I want to have some noise reduction. And now it gets interesting. You can not only import BIM data, but any object data, which means now in this case, I created 2 noise barriers, which I took from Sketchfab. It takes a second. But from a normal design program, and this is a noise barrier. And in order for people to be able now to cross that little valley on foot or by bicycle, I also want to implement a 2-span pedestrian bridge, which is, there you go, which is here, and that's also an IFC model. How can I prove it's an IFC model? I click onto it, and it usually gives me, if it's this is a simple example, let's go to this one. It gives me the IFC entities, okay? So basically, this is what you do, and when you're done, you can have a scenery that looks a little bit like this, and you don't have to take pictures because you get the story anyway at this project. So you have the different assets, you have my house, and you can also load, let's say, traffic data like this truck into the scenery, okay? And it's very detailed and very fast, in my opinion. Okay, and then of course, like if you go to share this story or this project, this is what you get later on. I give you the QR code. It will give you the view on this project with the widget on the left and the different pages. I think that's pretty clear. If you go to live demo finish, it jumps directly to that scene. If the internet is fast enough. Okay. Now you might ask, like, okay, that's good for a greenfield approach, but what do I do if there's some brownfield? So I want to switch off elements that are disturbing or stuff like that. So in order to do so, I think the most important part you have to understand what I was showing now was out-of-the-box technology. But if you want to build your own BIM viewer or digital twin viewer, you can also do that on CCM.js. What you see here basically is the same scene that I loaded into my own personal viewer with a widget on the left that I can switch on and off. And of course, I loaded all those assets. And remember the building with the green foundation plate. If I don't like that, I can implement a hide algorithm where I can just click on this one and take out single elements from the IFC files, or look into this building, take this wall out, and look into the HVAC. The same works for this building over there. Is more interesting. Take this out. It's still a prototype, whatever. All right, so basically this is the scene I created, and you see on the right side here a more extensive metadata viewer. So if you want to build your own BIM viewer that integrates all that data you can use later, you can easily do that, and you don't rely on any out-of-the-box solution. And of course, there's a little, let's say, management area over here where you can switch on and off the assets. Another thing I wanted to show a little bit more into structural design is I created more construction stage application. And that's the beauty. And I can encourage anybody to go to sandcastle.csim.com to create their own little applications. And by the way, AI helps you a lot. So all the code I created here, I did not write myself. I asked Claude AI to do it. And it works very, very well, up to 4,000 lines of code. So in this case, I took a real bridge. I think it's a famous one from the IFC project, IFC Infra or so. And I told the application, please use the IFC category and filter. No, it wasn't IFC category. No, I did something different. I took the IFC file, created another custom attribute called stage, and I assigned a value to stage. And then I let the program read, check which stage is embedded for each element. And then you can, of course, do a construction sequence, which looks like this then. So it switches on and off, of course, the different elements, and you can do a construction sequencing animation, and that's also possible in color. Second thing I wanted to show was right? BIM to field. So I thought about a use case like, what if you could take the model easily to the field on your mobile device, and maybe when you do the rebar checking and rebar approval, the distances and everything, you want to have the S-design model of the reinforcement. Could help a lot. And I created, again, make it standalone. Looks nicer. That was the wrong one. This was. That's it. Yeah. And this will be, unfortunately, the last example I probably can't show. Again, here's the bridge. I switch off the shadow, which is not necessary for the moment. Again, this bridge is geo-referenced on a pretty flat terrain. That's why it looks so odd. And if I go closer, what I can show you is that I can switch again off elements. And when I do this, I think the reinforcement is here. I go closer, we see the full 3D reinforcement. This was coming from Revit. So this is a direct import from Revit, but would work the same way with IFC if the reinforcement was in there. And if I, oops, probably crashed. Yeah, it crashed. Anyhow, you can picture this. So the good thing is I just let the code run again. And it's runtime code, so it's JavaScript. So if it crashes, you just let it run again. And again, I want to finish my presentation by showing the example then full-fledged. And what I will do is I switch on the category filter, and I will say the walls should be off, and then the slabs should be off, and zoom into the model. And one of my friends asked me, like, and this a guy is using Revit, can I color code the reinforcement as well? So those are the colors that are, the colors are derived from the diameter of the rebar. So if anything that is in the meta data, I can visualize here in this viewer. And now think about like 100 bridges. I don't have to open 100 projects. I just load them all into one viewer, because the beauty of 3D tiles is they only load when you move into the scene, which makes it very performant. Okay. I think I have 2 slides more. Yeah, conclusion, think beyond the BIM model. I think BIM isolated has less value. I think both approaches, geospatial and GIS and BIM complement each other. Web native digital twins are accessible, transparent, scalable. Hopefully I could give you an impression about that. Open source technologies, very interesting, foster collaboration, drive innovation, in my opinion. And doing that stuff that I've shown you, I have 1 year of seasoned experience now. So I'm a structural engineer, not a programmer. This is what I could create with 1 year dealing with the technology. And I just can encourage everybody and approach me, build your own digital twin app or cesium app. It's not that hard. It gives you a lot of value already. Resources, and I will share those, and you can take pictures that I would be looking into. It's the repositories of the JavaScript libraries and other stuff. If you want to take a picture of this one, this is important. That gives you access to the story I was just showing. And of course, I have a counter. I can see how many of you were using this. And last but not least, nothing closes without AI. Remember that fancy building where I shut off the foundation plate? That's from, it's a BIM collab example, used to be. So I created this rendering on the right with AI Studio by Google. I took a screenshot of the FreeCAD model and said, can you position that with a photorealistic rendering in a desert-like setting on a wadi, on a cliff, and the background should be a 4-lane freeway. And this is what Google AI created from that screenshot. It's crazy. This concludes my session. I'm open for questions.
Have you implemented any security?
All open, purely open. Yeah, good point. So, I mean, JavaScript runs in the browser session, the memory of the browser. That, of course, gives you a huge access to, there's a huge hole. And basically, but what you create is a website. So if you want to protect your application, use any website protection, like a password or so. So anything you can use on a website to protect a website, you can protect your application with. And yes, the whole source code is running in the browser. Pressing the F12 key will give you access to the source code. Clear. There's a token management system for Cesium, for the commercial version, where I can say that token only is good for that domain, for that asset, only read and write. So you have to do an active token management to give people access to an application, but that could be done as well. Sure.
You just turned off the element of the model.
Mm-hmm.
How about the Cesium cloud, there's an existing building there, and you turn off the existing and the building?
Yes. So usually an existing building, let's say an OSM building or CityGML building, is one element. If you're interested, I can show you, especially in a brownfield approach. If I put my building into a city context and there's already, let's say, a CityGML building, it's redundant. So you want to shoot off that OSM building. Yeah, that's possible. It's called a hide feature function. True that is. And second, I couldn't show that. If you want to cut out terrain, let's say you put a bridge into a brownfield, you want to cut off the terrain. And you can use a clipping function to cut out terrain and position your asset there. Okay. Also, maybe interesting, even though it's not open source or openBIM, there's a direct plugin for Revit. You can use your Revit application, choose a 3D view, use the Cesium plugin, say push to Cesium, and it's even almost quality-wise better than IFC because it transports all the materials and textures very well, which IFC is not capable of. And if the Revit model is georeferenced, good, and you have the EPSG code, it lands exactly at the position where it should land. Okay. Two more questions? Oh, in the back. Sorry, two.
Just going back to the definition of a twin of having a physical thing, a virtual thing, and then that live connection.
Yeah.
Where do the platforms capabilities for sensor view that are operational?
Yeah. So good point. I couldn't show that. I implemented something for a customer. I can show you later on. Anything. I mean, there's an IoT function in Cesium as well that connects live data from IoT sensors. You can integrate. Basically anything, I mean, the simplest form would be, for example, to embed an iframe that shows you live weather data from a certain position of your asset. So it's not necessarily IoT sensor data, but if you want to understand what the water levels are at your bridge, you just import that data. If there's an API, you can import the data and visualize it. If you want to visualize which airplane is over your asset at this certain point, you can use an API that gives you access to the current aircraft traffic, which might be important these days.
Did you try to integrate some underground infrastructure?
Heavy. Good point. There is no underground in Google Earth, and there's no underground really. Like what Cesium is giving you is the sphere and the terrain on top of the sphere. So underneath the terrain, there's empty space. So, but you can create an IC file of a soil model, for example, or underground model, and load it into Cesium. But you have to basically create your own underground volume model. And yes, then it would be possible. So taking, let's say, a whole supersurface structure and the subsurface structure, and if it's underneath, you can investigate as well. You can turn the terrain layer transparent, for example. But it's not really the typical application for that. You probably would rather use EVO by Sequent or so if you have a more substructure kind of approach to things. But would be possible, yeah.
Yeah, but it's not very common that we only build a bridge without having the link to the roads and the networks on either side.
Yeah, but you see my pile foundation. Yeah. So if you want to have the integration of the pile foundation with the subsurface, with the soil model, you have to create your soil model with volume elements. And then if that's capable of being created in IFC, you can import it. I can show you that as well. All right. Thank you.
Thank you, Christof.
Thank you. Sorry for the laptop.
No, that's okay.
I switch off this microphone, right?
Yes. That's great. Thank you, everyone. Just give us a minute while we switch over to the next presentation. Mattia, if you'd like to come up.
Okay. So good morning to everyone. I'm Mattia Mangia from University of Salento. I'm a research fellow, and together with my colleague Mariella Ferraro, We first of all would like to thank you, the audience, for being here, and we would like to thank you, buildingSMART International, for the opportunity. We are, as University of Salento, a small reality that is in south of Italy, and today we will show to you some projects we are working on, which are related with the adoption of openBIM approaches for BIM, GIS integration in cultural heritage. So I will just 1 second leave the word to Mariella so she can introduce to you our reality. I think you need to. The mic.
Okay. Good morning to everyone. I'm Mariella Ferraro, and it is a pleasure to be here to present to you our most recent works about openBIM and cultural heritage. University of Salento is located in Lecce, in the south of Italy, in Puglia region, and this year it celebrates 70 years. Lecce is a city known for its particular architecture, named Barocco Leccese, which is characterized by a rich decorative style mainly based on a particular type of stone known as pietra leccese. Our historical buildings, however, currently suffer from common cultural heritage problems, such as progressive deterioration or aging. These are issues which affect tangible cultural heritage in general and requires protection, restoration, and conservation operations. We would like to quickly introduce the common types of challenges on TCH. Physical and cultural degradation like erosion and atmospheric agents, natural and environmental hazards like earthquakes and geological instability, management and storage issues, for example, lack of funds and resources, anthropogenic impacts, tourism and disaster and wars, overcrowding and mass tourism, challenges in digitization and documentation, like absence of standards for the creation of digital twin or of historical heritage, challenges in retrofitting and adapting to modern regulation, like complex same-sex retrofitting without altering the historical value. Inappropriate risk management and lack of timely action can engrave conservation status of historic buildings and archaeological sites, requiring ever greater investment over time. The application of innovative solutions could improve the management and enhancement cultural heritage is slowed down by the reduced availability of public and private funding.
Okay. So from these premises, unfortunately, this doesn't work. Okay. We will show to you now some projects we are doing right now with University of Salento. There are 2 projects which are under the Changes broader project, which is an initiative in Italy, which derives from PNRR funds. And we are working now in 2 projects. The first one is Spider, sensor and 3D printing for an innovative and detailed exploration of local resources, and Project Villa, virtual integration for landscape and legacy architecture enhancement. So what we have done, we found out some of our small municipalities. You have to know that Lecce is a province in the Puglia region, which is characterized by a very highly fragmented set of small municipalities, which have few inhabitants, but they have a significant cultural heritage, which is now aging and is subjected to the problems Mariella presented to you. Along that, we have another problem, because we would like to preserve our cultural heritage, because like for the sake of science and history and so on, and also because tourism is an important factor in our region. But we have a problem in maintaining and preserving the healthy condition of our assets, of our cultural heritage, because we are suffering severe brain drain, skill shortage. We lack mainly the critical mass of professional and architecture and engineers and stakeholders which can properly work on this kind of assets. And we are also having struggle in trying to promote and to adopt BIM and GIS technologies as intended, as we would like here in buildingSMART. In particular, what are the consequences of these problems? Is that our historical heritage, which is of great value, is exposed to degradation, climate change, and anthropogenic risks, and it's kind of a scale effect. So the more time pass, more evident the damages and the degradation level increase. So what we are trying to do with the project? First of all, I would like to introduce you the Spider project, which is a project in which we did, it's not mainly BIM based as a project, but it's a project in which several disciplines and departments of our university collaborated. We had Professoressa, Professor Carola Corcione and Professor Mariangela Lazzoi, which are from 2 different departments. Lazzoi, the laboratory is where I work. It's related with digitalization of built environment. And Corcione instead is a lab related to 3D printing with innovative materials, like with some kind of material derived from waste of stone and quarries and so on. So what we try to do, we first of all try to capture the reality of one of the many buildings we have in our region. In particular, we have this palace, which is called Palazzo Marchesale, which is a massive building, which is located in Motrugno, which is instead a very, very small hometown in town. And the problem is that we see a clear mismatch in the comparison between the asset which requires maintenance and intervention, and the capability of the municipality. So we have a municipality which totally lacks any knowledge about BIM, not only about BIM, but also about a broader term which in Italy is taking place, which is called Gestione Informativa Digitale, which means digital information management. And so we captured a critical situation in which we have maybe the tool, we have some people which know the technologies and the processes, but we lack the infrastructure, the critical mass to properly implement them, even for use case intended for restoration, conservation of cultural heritage. Go on. So what we did as our technical lab did a very common HBIM scan to BIM process. So we did a survey with unmanned aerial vehicles and terrestrial laser scanner. And then we also try to promote an idea of a survey which is not only geometrical and focused on the geometrical part of the building, but also to extend the concept of survey to other physical dimensions like temperature and humidity, with some sample room in which we collected also IoT, Internet of Things sensor data. So once we had this very huge point cloud, which was like 50 gigabyte, which, as Dr. Lorenz said, point clouds are nice, are very cool, but we don't use them for measuring and for anything. So we need to understand how to transform it. We can do a reality mesh, HBIM models, which level of detail we should try to aim for which purposes. And we see here, we saw that the main problem was, in fact, the use case. Because the municipality knows that its building is suffering, is degrading, is in a level of degradation, but doesn't know which decisions it needs to take to preserve it. So the BIM model should be useful in some way. We tried to understand how to provide some quick access to detailed data. So we try to examine the point cloud, the one from the terrestrial scanner and from the drone. We collected a huge amount of data, like the photos from the BLK, from the laser scanner. And then we understand, together with the other lab, which instead was focused on cultural heritage and more about the preservation, even not only of the architectural components, but also of the artistic values like status or some other details of the building, to understand if once you did a very significant effort in doing a survey, which it was costly and was also time consuming, to understand how from one single campaign of retrieving data, you could take the most value without spending money for other purposes. So we try to segment the point cloud for extracting some particular features like the detail on the arc or the whole portal. And then we tried some pathways, like if we need this model for purposes of visualization or for some work related more with, in which it is required to have a high detail of data, of not of data, but of geometries, we could try to provide some mesh, like in this one I did a simple workflow from Cloud Compare, creation of the mesh from the extracted component we required, and to put them on the BIM model. But in some cases, maybe the user needs some more detailed requirement, some more detailed data, and especially some geometries which can be handled or parameterized or can be converted in an object type library, which in HBIM is one of the main problems because you have not a standardized catalog of types, but you have very different components, even shifting from one portal to the other one. In this example, we tried to define some families and some part of the building. But the main problem was that when we were talking with the stakeholders, so the major or the technical office of the municipality, we found out what we already know, that they don't have the, first of all, the IT infrastructure for managing this kind of data, but especially they lack the human infrastructure for handling this type of data, and especially processes, because like the knowledge about how to exploit survey data to provide BIM models, or not only BIM models, in general, digitalization of the cultural heritage assets, is some kind of knowledge which thrives in our context to get widespread. Along with that, in Spider project, the geometries from the survey data were also used for the other lab, which was focused on 3D printing of components like the baluster or some kind of details, like the emblem on the right is 3D printed. It was collected from a mix of survey data taken from the point cloud, so it can kind of provide some basic geometries upon which the 3D sculptor made some more provided the detailed model with the Blender working on the details. Along with that, then they 3D printed the emblem for, in this case, the purposes was for providing some gadgets related with the building, but what we would like to do in the next future project and future efforts is understanding if the digital data we captured can be used for providing the basis for the development of 3D models, which can then used for refurbishment, for example, for renovation purposes. Along with that, then we did some infrastructure, because we used your tools for building our own application, which is was done in collaboration with Videosoft, which is a software company from our place, which is a very good reality we had to know thanks to this project, and Janus, which is another startup from Rome, which has expertise on 3D survey data. And the main objects were mainly three: providing training and know-how on BIM, GIS, and digital solution to mitigate the knowledge gap which affect the local context, and providing a technological solution that can support the management of knowledge and decision to be made regarding TCH assets. In addition to that, trying to understand how everything could be used in a kind of agile and scalable way, because as I said earlier, we have a severe problem of brain drain and skills shortage, and we need to take this as a design requirement when we develop our solution. In particular, this is the overall overview of the software architecture we employed, we defined for the for this kind of solution. We use a PostGIS because the platform is not only 3D BIM GIS. It does not only have this module, but it also has a 2D GIS and a BIM viewer dedicated. So we have like a solution which is has 3 modules because it was required by the project from the stakeholders to still preserve the 2D visualization, which is always useful in kind of the territorial analysis, and also a specific BIM viewer in which maybe the single model can be, or a set of model can be explored without the environmental context. But mainly what we did is then developing the BIM.js model based on Cesium, and in particular the solution was intended to serve a specific purpose. It was based on representing the cultural heritage, not only the existing one, but also the previous, a lot of knowledge which we know exists from sources, but we do not have anymore. So in this case, University of Roma La Sapienza provided us a BIM model, the one in the center, which is also lighted in the screen on the right, which was a BIM model detailed with several data which the architect and the archaeologist put together to provide a simple BIM model with, in particular, 2 kind of information which was fundamental for them, for their analysis. The unità topografica, which some kind of clustering of the buildings depending on what part of the building it is, and the other was simply the period of existence. So we had like the time span of that component or of that complex of element. In particular, what we tried to, as a requirement, was also important to properly manage the location of the building, because we had a particular requirement related to the elevation of the building, because what they have are sources from buildings which were which now would be underground, were on a completely different level compared to the building of the subsequent epochs and so on. And also like the in general the planimetric, so x and y coordinates, latitude and longitude, which was used was implemented in the BIM model, especially we used IFC 4.3 model, in which we examined how the coordinate could have been managed along with the IFC site attribute or the IFC projected system. And it was also required because it was important for the end user to have some kind of platform in which the models could have been inserted and correctly geolocated without manual efforts or manual adjustments. So what we found out, obviously, that openBIM is it's now in a very good, in our opinion, in a golden moment, because in a golden period, because we now have Blender BIM, which is now called Bonsai. We have some update. Also IFC.js, which changed to that open company. A lot of change of nicknames. We have Cesium, XBIM, IFC OpenShelf, the fragments, which is the format from which IFC.js builds upon. And we would like, along with the BIM, with the buildingSMART openBIM standards, because we were talking now about only the part about geometries and managing of data on a web platform. We also have the use case management, BSDD, BCF, which now we still try to promote this kind of knowledge to our local context, but we have found a very high resistance in change management, and in particular the difficulty in staying behind all these new standards every year adds upon that. So we were thinking, if we explore use case management or also BSDD, we saw something about cultural heritage, from which we could in the future probably build upon for providing our proper use case management, or to focus and make them more specialized For instance, in the Midas heritage dictionaries, there are some entities which, for our case, were not existent, so we could contribute to that. But the problem is that these standards can be considered standards if only a few percentage of the industry is aware of this, while the other one is not even close to them. So, because the problem is that we saw some realities in which maybe one company or one a community was skyrocketing knowledge about BIM, GIS, and other knowledge, and then the whole partnership was completely lacking any knowledge. That hinders the possibility to implement and to use standards correctly, because if one fall, everything falls in our experience. So we have a significant amount of standards, of processes, of technologies, because technologies are there. We saw that Cesium is here, is open source. You can build your application. We did not use Cesium Ion, but we use Cesium JS, and but still we then lack the end user to make some proper use case management and to understand which are the way and the processes for exploiting this kind of data, which, spoiler, cost a lot of money to provide this kind of data to the end user, and then the user doesn't know what to do with that. So our context then is one. We also would like to make you know that it's not a singular situation. We have the broad Italian context is packed up with a lot of municipalities which don't talk each other. So maybe you can find in one example a municipality or as public agencies which is well known about BIM, which is well aware about BIM, but it's very common instead the other case, the other situation in which we have a complete unaware context in which one may be a BIM expert, but if everything else is not on the same level, or at least on an average level, we miss the whole point. It's in particular interesting. How many minutes? 5? 5. It's interesting, this article about Chiara Rizzarda, which is one of the most interesting writer about BIM and HBIM, and she's also known as a Shelidon on the website, on the web. She provides very interesting articles and reflections about where BIM is going and where it will go. She talks a lot about standards, about also the philosophy about BIM. What are we doing with this super detailed model if the end user can't use them? This is a very nice article. I suggest you to read, because it was used for us to be a bit more critical about HBIM, because HBIM, and compared to a BIM model, requires the survey data, and so we have a very good source for providing new information. But what is its use? It's also interesting, the article about Lovell, which try to provide a formula about how to measure a bit what is the usefulness of the BIM model, and if it will at the end match that intended level of utility of usefulness. And in particular, what we saw with this HBIM model we developed in these projects was that we were shifting not about a comprehensive model for everyone, but a collection of models which then we should try to link them together, but they are several different representation of the reality intended for specific users. So we are shifting towards a multi-model awareness, citing Rizzarda, which is not an MVD. It's not an information model as intended by the ISO 1960-50. It's a collection of information container which then can be considered independent information model, and we try to understand if there is a linkage between this information model and not with the information container. This means that from the point clouds data, we would like to provide multiple models, not multiple information container for different user. And just citing a childhood memories, I don't know if you know Digimon. I saw the audience is a bit more, it's not so not from my age in general. But what is Digimon? Digimon is funny because they get some tiny furball, which then evolves in a lot of different forms. And we thought the same about the survey data, which can be the starting point from providing different independent model. Oh, the point cloud just, okay. From which we can provide a BIM model, a point cloud model, or a 3D mesh model, which is intended for cultural heritage, for art and culture, and so on. A model for restoration experts, so some detailed components of the building, which they don't link each other. They are several parts. They are several different parts that can be developed in an independent way for specific user. And then also the photographic report or the hybrid model, so a model in which meshes and IFC components can be put together to have some detailed parts, while other can be used for facility management purposes or asset management, providing then at the end some more combination of tools for the platform like the one in the Village project, or in the future virtual reality, augmented reality application. But all of them are not one single model, but are different information model, with each of them a specific exchange information requirement and a different organizational information requirement. So in the end, we would like to close with this reflection. The problem is that in Italy we have also the decree, which is at the BIM mandate, for which BIM is mandatory in Italy, but especially for the cultural heritage, we have some exception in terms of the minimum level of the cost of the works for being mandatory. But still, we strive with a situation in which we are finding a very hard way to promote this kind of knowledge and to make them stable, because maybe we can even have some talent which is in our place for a short time, then he leaves, and we just lost a lot of investment done in creating this critical mass of knowledge and requires and the skills we need. openBIM for sure could be a very important way to make easier the widespread of this knowledge and to disseminate the results of openBIM, because openBIM, then we saw them as an open source technology, which needs to be counted along with the other open source technology, like for GIS or for other kind of application like Blender, BIM, and Bonsai, or Cloud Compare for point cloud manipulation, or any other application which can be used for different purposes. But the main problem is, for us, in our opinion, the fact that everything could be done, technologies are here and processes can be implemented, but we don't have the use cases. And why we don't have the use cases? Because the end user doesn't know what to do with them. And that's the main question point we would like to solve at least for our context, but in general, we think it's a general problem which could be pretty common. In the end, I would like to thank all the contributors to the projects. So this is the whole list of the collaborators for the Spider project, Ville project, and our lab, which was in both of them. And okay, references. And that's the end. Thank you for the attention.
Are there any quick questions for Mattia or Mariella? Just one over there.
Yeah, thank you for the presentation. It's knowledge of maybe what's historically happened to build more or less a digital representative, how it would look like in the nice days when it was really built and fresh and new.
Okay, if I intend right, you mean about this history of the building, so about more textual documentation, you mean something about understanding which was the evolution of the building, not only related to the geometrical aspects, but what happened, like if there were some wars or some earthquakes, some information like that, how we collected them?
No, normally the objects show a special kind of degradation, or some deep parts have been turned off. So do you plan to reconstruct digitally how it would look like?
Okay.
To really show it
Yeah, that was in the Ville project. Like there was the building, the temple, it was the model they provided us was currently as it is now, but they asked us to also, since they are working on the previous model, how it was, and in the platform they need to understand. They have we implemented a requirement in which we have a time slider, which the model has the lifespan of each component, like a single column was built in 100 after year 100 and was demolished, was destroyed on year 300. We have these two data, and we managing the slider, we can check which kind of elements were present in that lifespan. So we can have like the temple was before some significant event like an earthquake or a complete destruction. But it depends on the user if he has the data, and it is what also we wanted to address, that the survey doesn't end in the geometrical part, but also starts from the reconstruction of the history. So in the Spider project, instead, there was a research team which also worked on building the story of the building, and from paper sources, trying to have how it was back then in like 500 years ago. How was the building? So a BIM model could provide the model the historical model. Yes.
Thank you, everyone. Thank you, Mattia and Mariella. Just allow us a moment while we switch over to the next presentation.
Okay.
Thank you.
Hello, everyone. Good morning. Firstly, a few words about myself. My name is Mauro Coletto, co-founder and CEO of Serasoft, and I've been working in the field of infrastructure and topography software for more than 30 years. At Serasoft, I'm responsible for technological innovation, software development, and BIM work methodology. A few words about the company. Serasoft creates and markets BIM software solution for surveying, infrastructure design, road, railways, and hydraulic, and construction industry. Serasoft products are available in several languages and are adapted to comply with specific requirements of several countries and several standards. Okay. Serasoft research works cover a wide range of software applications with a particular focus on information model in open format for transportation infrastructure, such as road and railways, through the design, construction, and operational phases. I will present the result of our research in today's talk, focusing on the use of the IFC format in key verification and checking activities, starting from the design phase. The work is based on our experience in checking and validating road projects using more than 18 standards. It all started with customers' difficulties in ensuring the quality of road infrastructure information model through the BIM process. There is an emerging need, integration and management of roadway information model in open formats, to ensure that information model in open format accurately and consistently represent the object they describe during both the design and construction phases and in management and maintenance activities. Only in this way can the model be used to verify and ensure compliance of the roadways infrastructure with the regulatory, functional, and safety requirements. Unfortunately, our experience has shown that this is often not the case due to inadequate workflows and software tools. But when we can say that the information model is an information model of a road, it is when the model includes enough information to perform analysis on the road and directly determine the design choices, geometries, and characteristics of the road. The fundamental information required includes regulatory data, reference standard, dot type, typical cross-section, alignment, the definition of horizontal and vertical alignment, super elevation and widenings for road safety and functionality. And this can only be done using FC 4.3 and the later version. In the case of road infrastructure, model validation is a more important check than clash detection, because if the model is not consistent with the design and does not comply with regulation, it is an unusable model. Clash detection and other checks on unvalidated road information model are useless. And it should also be noted that in road infrastructure, clash resolution is primarily an integral part of the road design activity, and not the subsequent checking and coordination phases. There are several very important validations that we can perform. Following are the main ones, divided in 3 categories. The first category includes checks to verify if the road has been designed correctly and comply with the standard. It includes 4 validation. Validation of the design parameters, validation of the horizontal alignment, vertical alignment, and side distance analysis. The second category includes checks on the consistency of the geometric model with the design and include 3 validation. Validation of the geometric model with vertical alignment, with super elevation, and with widenings. The third category checks the validation of non-geometric information content using IDS files. And now the results. The classes and the p-sets of the FC 4.3 format, essential for correctly managing the information required for model validation, are p-set road design criteria common, that contains information on design criteria related to the road infrastructure, IFC alignment for the horizontal and vertical definition of the alignment, IFC referent for super elevation and widenings, IFC road part, and IFC course for the definition of structure of the model and geometry, and IFC property set and IFC property for the integration of information useful for functional and regulatory verification. And now let's go through this point one by one. First, p-set road design criteria contains the following information. The highlighted ones are the most important for functional verification of the roadway: design speed, lane width, road design class. But the information in this p-set is not sufficient to fully describe the road. So in this case, we introduce a custom property set. We introduce a Serasoft road design criteria, which includes additional useful information, particularly on the shape of the typical cross-section, enabling verification such as side distance analysis. We have 3 groups of properties. The first is regulatory properties, road design policy, road design class. The second is alignment and geometry properties, longitudinal slope, transversal slope, and design speed. And the third is for the typical cross-section property is a typical section type, line number, traffic divider width, roadside internal width, etc. FC alignment. FC alignment represents the alignment of a linear infrastructure, roads or highways. It defines the geometry of the path and is crucial for modeling both the alignment and the characteristics of the linear infrastructure in a BIM project. It's divided in 2 main components, horizontal and vertical. Horizontal alignment defines the path of the infrastructure along the ground level, and vertical alignment defines the elevation changes along the alignment. IFC alignment is the fundamental element for any road design, serving as reference for all related components in the infrastructure model. About IFC referent, values of super elevation and widenings are inserted using the IFC referent class and using 2 specific predefined types: super elevation event and width event. FC 4.3 introduces classes for defining the physical model of the road and its structure. We have FC road segment, and FC course, and etc. The FC road and FC road segment object of the road can be positioned via the FC linear placement with respect to the referenced FC alignment. This creates a link between the physical model and of the road and the alignment it refers to. FC property and FC property set. Using FC property set and FC property, we integrate valuable information into FC object for specific verification and validation. For example, to enable alignment verification, we added custom properties set to FC alignment segment, incorporating additional information. In this case, in this example, we use start station, end station, length, radius, a parameter, and maximum speed. To help you better understand how this works and how to apply this information in practice, I will give you a short example using our implementation. Okay, to validate a road information model, software is required that can correctly interpret the information contained and manage the necessary verification and analysis. We have integrated FC 4.3 file management capability into our solution for validation purposes, including model creation, rating, and managing validation activities. In this example, I use SierraSoft Infra Design Studio. It's a BIM software for railway, roads, and hydraulic design. But our example will focus on a road. Okay, through the import, we start from FC file. Through the import, all information in the file is loaded into the SierraSoft Infra Design Studio. Okay, we start with an empty file because all validation activity will take place using the information contained in the FC file. Okay, we create a new empty road and leave the regulation undefined. By adding a BIM exchange style, we define the rule for importing the road from the file. First step is to select the alignment to be imported from the existing alignments in the FC file. We select the physical road model referring to the chosen alignment. In this case, we select the model from FC linear placement because our model uses FC linear placement. But if the physical model does not use FC linear, the FC 4.3 model is loaded with all its geometries and data. The property set, PSET road design criteria and SierraSoft road design criteria are loaded, and the software automatically configure the design parameters. All elements of the horizontal alignment were loaded into the project, straight elements, curves, and transition curves. The same for all the elements of the vertical alignment, grid line and vertical curves. All super elevation values are also loaded, and the same for the widening values. In the end, a complete road information model is obtained with all objects, geometries, and data included in the file, in the FC file. And now we can start with the model validation. The first category includes checks to verify if the road has been designed correctly and comply with the standard. First, we activated the control panel to enter the checks to be performed. And the first validation, the validation of design parameters, checked that the design parameter within the FC file match to the standard set in the verification software. The software found 3 issues, and the design parameter within the FC file are not consistent with the regulation, and we have to correct to. The second validation, the validation of horizontal alignment, check the individual elements of the horizontal alignment against the criteria set by the standard, defined by the standard. In this case, the horizontal alignment does not comply with this regulation because we found 3 issues. Is the minimum length for the straight and a parameter for aclotoids. Third validation, the validation of vertical alignment, check the individual element of the vertical alignment against the criteria set by the standards. And here we have the same 3 issues. The vertical alignment that do not comply because we have the wrong values about the radius of the vertical parabolic curve. The last of the first group is side distance analysis. Using the information in the model, it's possible to perform the side distance analysis. In the generated site diagram, we find the road segments where the side distance is not verified. These are the most important checking for the policy, for the standards. The second category includes checks on the consistency of the geometric model with the design, which is a very important aspect, especially when the model is not created by the design software, when you use another software for the modeling. The first validation is the validation of geometric model with vertical alignment that checks the elevation difference between the geometric model, the surface of the model, and the design vertical alignment to highlight any out of tolerance. In this case, we have the red dots. There are the points where we have problems, and we have problems with the elevation. In this case, we have 61 found. It's 61 issues. Extracting a cross-section from the model, from the FC model, we confirm that the surface elevation of the model is out of tolerance with the vertical alignment. The second validation checks is the validation of geometric model with super elevation, and checks that super elevation are correctly applied to the geometric model, to the surface of the pavement, and highlight any out of tolerance. We have the 10 issues. We have the red dot on the 3D view. And in the cross-section, we find confirmation that the transversal lobe of the model surface differs and is out of tolerance from the design super elevation. Third validation is the validation of geometric model with widenings. That check that the roadway is sufficiently wide according to the widening values and reports any out of tolerance point. And we have the same in the cross-section. The cross-section confirmed that the roadway width is out of tolerance with the design widenings. The third category checks the validation of non-geometric information content using IDS files. And verification can be performed using multiple IDS files. Here we have 2 examples. The first validation check the non-geometric information content of the horizontal alignment element using the first IDS file, IDS horizontal segment. And there are 12 issues. There are several wrong properties value. And the second validation checks the non-geometric information content using another EDS file for check the wearing course, in this case. 3 issues for the wearing course. One is one value is incorrect, and we have the classification and the property are missing. Okay. At the end, all results are available in the side panel for further management and can be exported in BCF and Excel format. Finally, our conclusion. The importance of information model validation. Validation presented here serves to ensure the quality of the model before proceeding to checks and these specific uses. For example, clash, 5D, construction, etc. Validation is essential, especially when the design and modeling software are different. The FC 4.3 standard provides classes and PSET specifically to define the road infrastructure design criteria but the predefined pset in IFC 4.3 are partially sufficient, but by using custom property set, the checks can be complete and accurate. And using the IDS file, it is also possible to check the presence of design information for the alignment elements. At the end, the result is that with the right tools and a properly created IFC 4.3 road model, all necessary checks can be performed without relying on external information. And that's all. Thank you so much.
Thank you, everyone. Are there any questions for Mauro? Just one at the back.
So the IDS was used for the non-geometric checks, correct, validation?
With IDS?
With IDS. And the geometric information is using the standards built into your software, correct, for site distance?
So, no, I don't understand, sorry.
So the geometric information, what was that validated against? It wasn't IDS. It wasn't an IDS file.
No, IDS is only for non-geometric information, only for properties. Geometric is another part. We need to validate the geometric because we have to check if it's consistent with the design. Because if you use one software for design and one software for modeling, probably the quality of geometry are different. And if you don't use the modeler in design, you have problems that you have not solved in the design. It's a complex. Please.
Thank you very much, everyone. I hope you enjoyed the rest of the day.